Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about aromatic amines. Now you can see two different chemical reactions are provided here, and in the first reaction product is A and the second reaction product is B. So you have to say what is the correct structure of both A and B. Four options are provided and one of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Don't worry, after some time you will get the right answer. Now I believe you have tried by yourself, so it's my turn to give you the right answer. So let's learn the problem little closely. If you look at this problem, here aromatic amine or anniline is given, and in this case N,N-dimethyl anniline is given. And in both case student, the reagents are same. Means if I ask you more clear question, what is produced by this NaNO2 and dilute HCl? It produces this NO plus electrophile. So actual question asked here, what is the reaction between this anniline and N,N-dimethyl anniline with NO plus? So that's the actual question. So let's learn everything stepwise. So first, how this reaction happen? This NaNO2 first reacts with dilute HCl at low temperature. Student, this condition is very important, otherwise this produced in the HNO2 will be decomposed. So it produces this nitrous acid. Okay, and in the subsequent stage, this nitrous acid in presence of acid undergo dehydration. Means first it undergo protonation on this oxygen, and later on it produces this OH2 positive, and this water molecule leaves because it's a neutral leaving group, good leaving group, and it produces this NO plus. This is student actually the electrophile, okay, for this reaction. So what happens in the first case? For example, if you react this anniline with this NO plus, then this nitrogen lone pair act as the nucleophile to here, and it produces this N-N bond species. So this is the N-N bond, okay, and it undergo tautomerization. This, and in this way what it produces, actually these hydrogen shift from here to this oxygen, and it produces this N-N double bond with OH group. So this is the N-N double bond. See, reaction medium is acidic because NaNO2 dilute HCl. So in the subsequent stage, what will happen, that these lone pair of oxygen will react with H plus and produce this OH2 plus. Similar process, and in the next step this OH2 will leave and produce this diazonium salt. So this is diazonium salt, student. And in this case, why it leaves? Because there is additional lone pair here, so it pushes and this leaves. And not only that, this diazonium salt is in conjugation with this benzene nucleus. Means, so that's how this benzene nucleus stabilizes this diazonium cation. Okay, so this is the reaction. And in the next step, in this case, it reacts with N,N-dimethyl anniline. See, student, in the previous case, whenever this nitrogen attacked this NO, one proton was released to counterbalance the positive charge come on NO, this nitrogen NH2. So this positive charge on this nitrogen was counterbalanced by releasing one proton. Okay, and second, this tautomerism here, it also involves with this proton removal. But if this proton does absent, means this position is blocked by this 2-methyl group, what happened? This path will not be followed. Second, this nitrogen can attack, but this carbon nucleus, this benzene nucleus can do, means aromatic electrophilic substitution. Okay, and remember student, when nitrogen is attached to benzene nucleus, its ortho position faces two effect, means both minus I and plus R, but para position faces the plus R effect only. Okay, so that's why what happens here, this lone pair pushes, it comes and it goes attack this NO plus, and ultimately it produces the sigma complex. Later on, this proton is eliminated from here, it goes there and produces this aromatic compound. Okay, or more specifically, if I say para substituted compound, this para substituted compound, so para nitroso-N dimethyl aniline. So this is actually the difference in reactivity, that's you should know. So what is the right answer? First, so the one part is diazonium, another part is para substitution, so option D is the right answer. Now if this question appear in your exam less than 30 seconds, how can you come to the right answer? If you know just only one question properly, just aromatic amine in presence of sodium nitrite dilute HCl low temperature produces diazonium salt. It is a very basic fundamental reaction, diazotization reaction. So if you understand this, then option A and option C gone, just disappeared based on your common sense. Second, this NaNO2 dilute HCl react to produce B. Okay, so either orthonitrosation and paranitrosation, which is possible. Obviously paranitrosation is more favored. Not only that, these nitrogen is attached to two methyl group which are bulky, bigger, so steric interaction also possible in the ortho position, so para. So based on your very common sense, you can come to the right answer less than 30 seconds. But for that purpose, first you should study, and second you should practice new and new questions by yourself. That's the best way. So in conclusion, what you have learned today, that HNO2 is the main component for this diazotization reaction, and it is generated in situ in the reaction medium at lower reaction temperature condition, means 0 to 5 degrees centigrade. The electrophile, that is NO+, is generated by the dehydration of nitrous acid in presence of the dilute HCl. And here aniline can react with this NO+ and produce diazonium salt by dehydration process. And and they undergo dehydration to produce the diazonium cation. And this N-dimethyl aniline undergoes aromatic electrophilic substitution reaction, and it results in para substituted product. Okay, because para position faces the plus R effect only. And overall, the aniline or its derivatives are electron rich, and that's why they are activating for aromatic electrophilic substitution, and they undergo the reaction very efficiently. So I believe this video may be useful for you. I thank you for watching. If you consider my contents unworthy, then please help this channel to grow. So stay happy.